Hello, everybody. I would like to welcome you to the second lecture in the Food and Dairy Analysis course. Today, we are going to discuss two topics about the determination of moisture and fat contents. In each topic, we are going to discuss both the technical importance of the component under study, whether it is moisture or fat, and then we will discuss the methods used for the determination of moisture or fat. If we start with moisture, let's ask ourselves a question. Why is it important to determine moisture content? What is the importance of moisture for milk and dairy products? In fact, water is a major component in milk and dairy products. It makes more than 3/4 of the milk weight. You have to remember all the time that milk is a liquid, so it is mostly water. So it is water that contains other components. Water is the main component in it. For cow's milk, the percent of water is 87%. But what about the other milk types or milks from other animals? If we have a look at this figure, we will see that goat's milk, which is لبن الماعز, goat means ماعز, contains 88% water. This is to be followed by cow containing 87%, buffalo milk, لبن الجاموسي, 83%, and finally sheep's milk, لبن الأغنام, 80%. There is a similarity between goat, الماعز, and sheep, الأغنام, but they are actually from different genera and they produce milk of different chemical composition. So whatever the percent of water in all of those different types of milk, you can see that water is still above 80% of milk weight, which makes more than 3/4 of milk. But what about dairy products? This is for liquid milk. What about cheese, for instance? If we have a look at soft cheese. Soft cheese includes Domyati cheese, the white cheese we eat all the time during our breakfast or dinner. Soft cheese may contain from 50 to 60% water, and this percent decreases with hard cheese. Hard cheese like Rumi or Rasa cheese. It contains from 30 to 40%, but it is still a high amount for a component that makes it a major component, which is water. Okay, what else? What other points that show to us water is important for milk and dairy products, or in milk and dairy products? The second point is that water is the environment. It is the solute in which all the solid components exist. As we know, milk consists of water and solid components. Those solid components include fat, protein, lactose, minerals, vitamins, etc. All these components exist in water. And in fact, they exist in different forms in the water of milk. For instance, minerals exist in the water of milk as a true solution, whereas lactose exists as molecular solution. We can call both ionic solution and the molecular solutions true solutions. In this case, the solid components or the solid molecules are evenly distributed in water. But in other cases, for fat and protein like casein, they exist in different forms. For instance, casein exists as a colloid. Colloid means معلق. Whereas fat exists as an emulsion. Emulsion means مستحلب. So there are 4 different forms of solution existing in the same environment of milk, existing in the milk of water. This is quite amazing. This is very interesting. to find a single liquid, which is milk, containing 4 different forms of solutions. But what makes those different solid components existing in different forms of solutions? In other words, why minerals exist as true solution, whereas fat exists as emulsion? In fact, this is because of the particle size. If you have a solid component that has a small particle size, it is going to form a true solution. Let's have a look at this picture. If the particle size is less than 10 to the power minus 7, which means it is less than 1 part of million, like minerals, then it is going to form a true solution. But if the particle size is larger, between 10 to minus 7 up to 10 to minus 5, then it can form colloid. If it is larger than 10 to minus 7 to minus 5, then it can contain or it can form an emulsion. So based on this, I would like to ask you a question which you should be able to answer. Which are larger? Are the casein particles larger or fat globules larger? Casein forms colloids and fat forms emulsion. Which are larger based on this relationship between the size of particle and the solution form? Okay. Another point that shows to us why water is important, that water is the environment for all reactions needed for preparing milk products. In preparing milk products, for instance, in preparing yogurt, we need a reaction called coagulation. We need to coagulate milk. Also, we need coagulation for preparing cheese. So, for coagulation to happen, you need water. Let's consider this example. If you wish to prepare cheese and you have been given dried milk powder, لبن مجفف, is it possible to produce a cheese from milk powder? In fact, it is possible, but it is only possible when you add water to this dried milk. Water is going to make the environment for distributing protein, fat, and the other component in dried milk. And also it's going to make the environment for the enzyme like rennet to be added for milk coagulation. The last point on the importance of water in milk and dairy products, it's about the effect of water on the body and the taste of dairy products. Water gives softness and gives fat-like taste to dairy products. In cheese, when cheese contains more water, it is going to be softer, as we have seen in a minute. We mentioned that soft cheese contains from 50 to 70, but hard cheese contains from 30 to 40 moisture. So that's why the first one is soft. It's called soft cheese because it contains more water, and the second category called hard cheese, since it contains less water and has harder body. Also, water gives dairy products a better taste. It is a taste that gives you, it is a fat-like taste. So those are aspects that explain why water is important and why its determination is important for us. Well, let's move to the second part on moisture in milk and dairy products, which is the methods used for determining water or moisture in milk and dairy products. There are actually two methods for determining moisture in milk and dairy products. The first one is the so-called hot air oven drying method, and the second one is the infrared drying method. The first method, the hot air oven drying method, it is the standard method. So based on what we described in the first lecture, this method should be the highest selective it is of the highest selectivity, it is of the highest sensitivity, and it is of the highest reproducibility. It is both, it is classical and standard. But what's important here, it is the standard method for determining moisture in milk and dairy products. The technical principle in this method is to evaporate water in milk or dairy sample using high heat. Then you need to calculate the difference due to this water evaporation. This difference will be the moisture content. I believe that you have been aware of this method before, and you are going to do some sort of brackets during the practical session في الدروس العملية for this course. But I may give you an overview of the main steps in this method. So this method starts with weighing a sample of milk or dairy product in a suitable container, like what this guy is doing now. This is to be followed by exposing this sample to high temperature in a hot air oven. It is normally exposed to a high temperature of 102 to 105 for 3 to 4 hours. And then after the drying, we need to reweigh the sample after drying and calculate the difference between the weight before drying and after drying, which gives us the moisture content. Okay, you need to divide this. You need to divide the difference between weight before drying and weight after drying. You need to divide it by the weight of the sample before drying. And then if you multiply the quotient by 100, then you will get the percent of moisture in this sample. So this is the hot air oven drying method. It's quite standard, it is quite classical, and it is also a lengthy. It takes time. As you notice, it takes from 3 to 4 hours or even more for the preparation of sample and weighing and other steps. So it is a relatively lengthy or long method that takes hours. So scientists started to think about another method that may be shorter, that can be done in a shorter time. And they came up with the so-called infrared rays drying method, which is a rapid and modern method, but it is not the standard method. So this means it is less accurate than the hot air oven drying method. In this method, we use the same principle of evaporating water from the sample and doing or weighing the sample before and after drying. But in this case, we use infrared rays instead of hot air for drying the samples. This was an advancement in this method because it shortened the time for doing the analysis from 4 hours to around half an hour. But in fact, there has been another interesting development in this method, in the infrared rays drying method, that happened over the recent years. Some companies developed an instrument means جهاز, that can do all the steps, that can do the weighing step and the drying step, and gives you the moisture content or gives you the weights to be calculated. For instance, here is the so-called moisture analyzer. This is a commercial instrument. As you can see in this picture, it is basically a balance. Balance means ميزان. It is a balance, and its cover has a drying chamber, غرفة للتجفيف, منطقة للتجفيف. So as you can see, here is the balance, and that includes a container. Then you weigh your sample in this container, and the balance shows the weight, which is 20.742. Then you close the cover, you put the cover down, and operate the instrument for drying. when you close the cover, the drying starts, so the samples will be dried. And after few minutes, just a few minutes, you will get the sample dried, and you will get the weight of the sample after drying appearing on the balance screen. So it is now 19.025. You should be able to calculate the moisture content based on those two weights. The first weight in picture 2, 20.742, and the last one, 19, in the last picture 4, 19.025 or 25. So it's quite amazing development in this method. You use one instrument for doing both weighing and drying and even calculating the moisture content. I would recommend you to watch out this video on YouTube that explains to you in few minutes how a moisture analyzer works.